Hello everyone. In today's video, we're going to talk about Physics 253, Week 6, problem number 26.51. In this problem, we are tasked with finding the excess charge on a sphere given its potential difference in volts as well as the diameter of the sphere. So for this problem, we're going to be drawing on concepts from chapter 26, but we are going to be using equations from chapter 25. Specifically, our equation in chapter 25.4, I think, we're given the equation 25.31, in which we are given the potential difference of a sphere. So here we have our charge here in coulombs, as well as our radius of our sphere, and here we have our coulombs constant right here. So for this problem, I've gone ahead and drawn out a little charged sphere. There's not too much you can do for this one as far as the drawing aspect goes, but here's our sphere and here's our diameter, and it has some charge radiating off of it. I did end up deciding to put this charge going outwards after I solved the problem because it is of a positive charge. So getting into the problem here, it's relatively straightforward. I think one important thing to note is this relative to v equals 0 volts at infinity. This, I think, is just saying that the potential, this right here is the potential difference right here. And so we don't have to change anything or find a actual difference value because this is the difference. So just getting into the problem here, it really is just kind of rearranging some values. We're going to be solving for the excess charge Q. So pretty much all we need to do is rearrange this equation, and we're left with this right here, where we have our R times our potential difference in volts. So just plugging in here, as always, we have our permittivity of free space in farads per meter, multiplied by our radius, and here I've just taken the diameter and divided it by 2. And here we have our potential difference of the copper sphere as 300 volts. From there we can just kind of plug and chug. As we can see, we get this really nice 10 to the negative 9 here in coulombs, so it's going to make a really nice number in nanocoulombs, so I've just gone ahead and converted it. And if we take into account significant figures, all we are left with is that Q equals 1 nanocoulomb. So this is a relatively straightforward problem, but I think it really does kind of foreshadow what we're going to be talking about in either future chapters or maybe more advanced topics of potential difference, and that is this relative to the potential difference equaling 0 volts at infinity. I think that we might have to potentially solve for potential difference in different ways instead of just kind of recognizing that this here is our potential difference. I think that we're going to have to either integrate or potentially use different potential difference values to go ahead and solve for the value that we're going to need to solve the problem. So I hope you guys found this video helpful. Thank you very much for watching, and have a great rest of your week.